Hello, so I wanted to talk through some of the questions on the second practice test. I'm not going to go through all of them since many of them are straightforward. Um, let's talk specifically about question 10 since that one's more interesting. So we have a group of 10 friends going out to eat at a Chinese restaurant, and they sit down to eat at a circular table. So in the previous question, we had a pair of people who were dating, but now we have a pair of people who are exes who now refuse to sit next to each other. So how does that change the way we count them? Well, actually, it's very similar. Um, so let's start with trying to seat Claire first, okay? Um, right, we want to start by seating the people who are most restricted. So that'll be Claire and Daniel. So let's start with thinking about how we can seat Claire. We have 10 choices for how we can seat Claire because she can go anywhere around the table. But then once we seat Claire, that's going to leave us with only 7 ways to seat Daniel. The reason is because we can't put him here, but we also can't put him next to Claire, right? So that takes out 3 seats, which leaves us with 7 seats to choose from. And then once we have those two seated, we're able to seat the rest, and we have 8 people and 8 seats, so that's going to be 8 factorial. And then finally, we're going to be overcounting by a factor of 10 because arrangements that are identical after rotation are considered to be the same arrangements, right? So that means we have to divide by 10. And so in total, we're going to have 10 times 7 times 8 factorial divided by 10, which is 7 times 8 factorial. This one's pretty straightforward. Maybe I can talk about question 10. We have 5 freshmen, 5 sophomores, etc. in a 20-person class, and we're trying to make a group of 8 containing 2 of each grade. So we can start by choosing how many freshmen we make, how many freshmen we choose. We want 2 freshmen, and we have 5 to choose from. So we're going to have 5 freshmen, and we're choosing 2 out of them. So that gives us 5 choose 2. And then the same goes for the other ones. We're going to have 5 sophomores, and we want to choose 2 of them. 5 juniors, choosing 2 of them, and 5 seniors, out of which I want to choose 2. So in total, that means for each bucket, you can think of each bucket as each class. I'm going to have 5 choose 2 for each, 5 choose 2 choices for every single class, which means that in total, I'll have 5 choose 2 to the 4th power. You could have also done this by simply listing out the 8 people, and then you'll have 5 choices of freshmen for the first one, and 4 choices of freshmen for the second one, 5 sophomores to choose from, and 4 sophomores to choose on the fourth one, and then et cetera, et cetera. But then you'll also overcount here, right? You're going to overcount the order of the freshmen, and the order of the sophomore, and the order of the seniors and juniors. So that means every single one needs to be divided by 2 factorial, which means that in the end you would have 5 times 4 times 5 times 4 times 5 times 4 times 5 times 4 divided by 2 to the 4th, which is the exact same as this. Question 3, 13. It's pretty similar to the practice test 1, so I won't talk about it. Um, and all these are pretty much the same, except 18 is a little different because the probability is actually 0. Why is that? That's because we have 6 cards and we want each card to have a different suit. But that's impossible because there are only 4 suits, right? If we have, for the first card, we'll have 4 choices of suit, then 3 choices, and 2 choices, and 1 choice of suit. But then for the 5th card, we've run out of suits. There are no more suits left to choose from. And so the probability of us getting a different suit on the 5th card is 0, which means that the answer is going to be 0. Question 19, flipping a coin 10 times, what's the probability of getting 3 tails? I can talk about this a little bit. So in order to get 3 tails, we're looking for some arrangement of TTT, HHH, dot, 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 H, right? And so how many ways are there to order this word, TTT, HHH, H? There are going to be 10 factorial divided by 3 factorial times 7 factorial. 10 factorial because there are 10 flips, 3 factorial because we're going to overcount the t's, and 7 factorial because we overcount the h's. Notice how this is also equal to 10 choose 3, right? If you know the formula for the binomial, this is the exact same thing. So why is that? You can simply think about this like this. We have 10 flips, so we have 10 spots, and we're simply trying to choose 3 spots in order to place the tails. Alternatively, you could have written it like this, 10 choose 7. That means you have 10 spots and you're trying to choose 7 spots to place the tails. Oh, I'm talking right now? Yeah. That yeah, might need to leave. Sorry. Sorry about that. So you have 10 spots and you're essentially just trying to choose 3 of them to place the tails in. And if you think about it like that, you're not going to have to worry about overcounting because the 10 choose 3 automatically accounts for the overcounting already. So that means you're going to have 10 choose 3 total possible orderings for the 3 tails. So that's going to be our desired outcomes. And our total outcomes is still going to be 2 to the 10 because we have 2 choices for every flip and 10 flips total. Question 20 is a little tricky. It's telling us we're flipping a coin 6 times. What is the probability that exactly one pair of consecutive flips has the same result? So what do I mean by exactly one pair of consecutive flips has the same result? I'm saying like, for example, TH, TH, T. This is an example of a case where exactly one pair of consecutive flips has the same result, and that's this pair, right? Every other pair has a different result for the 2 of them. What would be something that does not satisfy this condition? For example, if we had TH, T, 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 H, this would not be true because there are 2 different pairs of consecutive flips that have the same result. This pair and this pair. Okay, so hopefully the problem makes sense. I think it's clear the way I've worded it, but you just need to really understand it, what's going on, right? So how do we count these kinds of scenarios? Well, the idea is first we want to think about which kind of consecutive flip do we want? And there are 2 choices, right? Either we have a double H or a double T, all right? Secondly, where are the possible places for us to place the double H or the double T? Suppose it's a double H. Well, we could place it in the first 2 positions. We could also place it in the next 2 positions, etc., until we have only one left, which is the last 2. And in total, you can see that there are 5 choices for where to place it, right? The first H can go from the first position all the way to the 5th position. So that is 5 choices. Now, the idea behind this problem is that once you've placed the pair, in other words, once you've placed the double H's, all the other flips are restricted, and there's only going to be one possibility for what kind of outcomes they could have. For instance, if I had, for example, my double H in the 3rd and 4th spots, then that means that this must be a T. That means the 5th flip must be a T because if it was a H, that means I would have a string of 3 flips with the same result, which is not allowed. So this must be a T. And if that's a T, then that means this can't be a T, right? Because that's going to be another pair of consecutive flips. So this must be a H. In other words, everything around the consecutive pair here has to follow an alternating pattern, which means that they're already set into place, basically. We can't choose anything else for the other flips. So that means once we've placed the double H or the double T, all the other ones fall into place and there's only one possibility. They're forced, right? So that means in total, we're going to have 2 times 5 desired outcomes. 2 choices for the double H, double T, and then 5 choices for where to place them. And that's it. And of course, the total number of possible outcomes is 2 to the 6 because we have 6 flips and 2 choices for each flip. Hopefully that makes sense. In general, for the test, you are going to see very similar questions. Okay, so you are going to see a question about a Chinese restaurant with a boyfriend and a girlfriend. You are also going to see questions such as question 19. You're going to see very similar poker hand stuff. You're going to see a question about A team, B team. You're going to see a question similar to 12. It's going to be very similar. So even though it's tricky, I'm giving you the problems ahead of time, essentially. The only one that might be a little different is question 20. It'll be different variations of these kinds of ideas. Hopefully that's helpful, and good luck.